let's say, yeah, all right, we'll use Jameer. Electromagnetic. All right, to, let's just say mechanical. All right, but changing from electromagnetic energy to mechanical energy would be the type of energy conversion that I'm talking about, okay? Or changing from thermal to chemical. Changing from nuclear into mechanical. Those are the forms that we're looking at. So I put 3 examples up here to talk about the type of energy conversion that you might have. So if we're talking about a windmill, windmills are becoming very popular in the state of North Carolina right now. Okay? Now, you never seen a windmill? You see one. Yeah, they're big, they're very tall, and they have usually about 3 propellers, and they spin. Alright, sometimes in the mountains they spin largely. Alright. I'm from the northeast corner of the state, and they've built a large windmill fan or farm out in the northeast part of the state. So there are hundreds of them in the northeast corner of North Carolina. So they put them out in the middle of the cornfield. What is state farm? North Carolina. What is Easy Farm? Elizabeth City. You ever heard of Elizabeth City State University? No, Elizabeth City. Why would you? Now, in Elizabeth City, they took a large cornfield and they got rid of the corn, but they built a windmill farm. All right, there's hundreds of windmills out there in the middle of the field as you drive by on the highway. They just plowed it under with a. Alright, so if they're building windmills, what are the purposes of windmills? What are they for? To make what? What kind of energy? Alright, the wind power is being used to make what though? Electricity. So we're using it to make electromagnetic energy or electricity. Okay, so what does it start as then? What does it start as? The air, the wind starts as mechanical. So it starts, there's no water in it. Oh, okay. Alright, so it starts as mechanical and it becomes electromagnetic. Okay, because it starts as mechanical, the blades turn, the point behind the blades turning is to make electricity or electromagnetic energy. Now, a battery. I'm just talking any old plain AA, AAA, DC battery. Alright, what kind of energy does it start with? So it starts as a chemical reaction. Okay? Starts as a chemical reaction. Alright, now, what generally do we do with a battery when the chemical reaction stops? We throw it in the trash can because it's dead. Okay? Sometimes you can put them in the freezer and slow the reaction down so it lasts a little bit longer. But generally speaking, when the batteries are dead, you just throw them out. Now, the nice thing about cell phones, and the things I like to do in here, is cell phone batteries are able to be what? Charged. We recharge them and we can do that over and over again. But even with cell phone batteries, over time, what happens to their batteries? They die. They lose their ability to be recharged. They have to be replaced. Or because the batteries are so expensive, what do we generally do? We just buy new phones and shit. Okay? So, when we have a chemical reaction in most things, a battery is used to power something, right? So what are we making? What's the chemical reaction producing? Energy. So it's making what? All right, it's making some form of electricity. So it's making electromagnetic energy. All right? Food. All right, it starts as chemical.
That's
That's what I'm asking you. What's it turn into? What do you think?
you drinking when you want to watch?
Okay. Think about your biology and your process.
What about your what?
Biology is a process of the same place.
Oh.
All right, you could argue mechanical. You could argue mechanical because it allows you to have energy for your body to do what? To move. I could live with that.
But it's not mechanical, Doc.
No, but you could argue it gives you energy to move. I could certainly live with that. All right. You could, I would certainly be fine with you telling me thermal because it's going to heat up on the inside of your body. The biological processes that go on. I mean, it sounds sort of gross. But when you guys pee your poop, it's going to be warm. Okay? It's probably not coming out chilly. I don't know how many of y'all have gone to the bathroom and came out chilly, but I don't think Okay. Moving on. Now, I need y'all to go grab a laptop real quick. You got a class flow. We're going to see if you can do something on your own. Like classflow.com/work. Yes, get your water. I don't know how you broke your nail. Hurry up, Chris. Hey! That's mine. You want to give me a rock? I have $1. Devin. Devin. You're broke. All right, remember, go to classflow.com/learner. It's on the board. Look at the corner of that laptop right there. Oh, hell no, bro. Somebody got a booger on that freaking laptop. Well, unfortunately, Kate Dark. Someone used it to do testing. I could have just gotten you a white and you put those whites around. Hi. Yeah, give me a white as well, because I don't get them out of the Oh, take his hands in because y'all cry. When on Saturday did you come in and do it? My God. No. .com/work. Yeah, type in the code that's up there on the board. That code is the same. So I know who's giving me what I need. First of all, you gotta type it. Up there. I can put it on board. All right, there. I told you. Remember that stuff on the computer? Anybody got any watch clubs?
Yeah, I just go right here.
Get on there.
Somebody chicken nuggets. Okay. You never know, but little kid might grow up and oh, he might.
Alright, is everybody where they need to be so I can send your car? Alright, we ready? No, go pick one.
Hey, I'm logging in.
Alright, did you get something? Yeah. I want you to tell me what type of energy it starts as and what it becomes. What does it start as and what do you think it becomes? Okay? What do you think it starts as and what does it become? You can type it or you can write it. I don't care which. I'm going to send it back to you. What do you think it starts as and what does it become? Remember the 5 types. Electro, mechanical, thermal, chemical, and nuclear. And what does it become? Which one does it start at? Look at the picture. It's a plugged-in Christmas candle. It's a plugged-in Christmas candle. Now it's got a cord at the bottom of it.
Bruh, shut up.
What I'm asking you. What does it start at? And it's plugged in. And what does it become? What I'm asking you.
Light plug in, it should be a new one. About 5 days, 5 days. All that.
Who did this?
Right.
Miss Wall.
Who did that?
Miss Wall. Miss Wall. He's so mad. Like, that just pissed me the fuck. I said 5.
I don't care. Don't use that one either.
You didn't get this one from me. I'm sorry, that is the dumbest thing I've ever Alright. So if we look at some of the answers that you guys came up with. Alright. I've got, stop. Jeremiah, stop. So I got thermal, comma, electromagnetic. So I'm guessing that started as thermal, became electromagnetic.
Is that correct?
Alright, I see it. I've got electromagnetic to thermal.
No.
I've got thermal to electromagnetic. Electro to thermal. I like the arrow. Electro to mechanical. Bang, bang.
Bang, bang. Who said bang, bang?
That's kind of useless, people. You need to go one back here. Candle. That's kind of useless. Thermal electromagnetic. Thermal electromagnetic. We got a whole bunch of thermal. I got electrical thermal. All right, so it looks like the majority of the answer is thermal to electromagnetic, and some of them have electro to thermal. Which one does it start out as if it's plugged in?
Oh, thermal.
It starts out plugged in.
It's not plugged in.
It's electromagnetic to start with. It's plugged in. Right? All right, so it has to start out as electromagnetic because it's plugged in.
Right.
Everything or most things that are plugged in have electricity running through it, so they get what? They get hot, so it becomes thermal. Okay? So electro to thermal was the right answer. All right? All right, did everybody get a picture?
Yep.
Tell me what you think this one is. What does it start as, and what does it become? What does it start as? This is a fire. Thermal. I'm asking you, what do you think it starts as? What does it become? Oh! The fool who wrote fire, or candle last time, didn't write fire. We know it's a fire. Okay, write down what you think it is, or what you think it becomes. Jeremiah. How does it get a chemical? They got evidence. I would not think think of it is we're actually starting the fire. Just assume it's already burning. Yeah. So if you put down mechanical because we started it, just resubmit. Assume it's already burning.
That's slow, bro. We can revenue participation.
I always think kindly of you when I'm doing participation. If you're on, let's say, a 59, 60, or you need a point in,
I need a point.
then I will always say kindly of you. Say, what you don't. I get 88, I got so much of I say, fix it on it. I have talked on it. I don't. And I won't do that. Hung up and got off phone and went and got my real phone. I was talking to my wrist. I look stupid, that guy felt stupid. All right, I'm gonna hit stop. All right, get it in here, here's the submitting one. All right, so if we look at what you've got, all right, we've got thermal to chemical, chemical to thermal, okay, chemical to thermal. Pick something behind this time. Thermal to chemical, thermal mechanical, thermal to chemical. I'm not sure why we just said mechanical because mechanical has to move. All right, apparently we wound up in show names. Oh, that was DeMarco. Apparently you belong at West Davidson with it. Correct. Okay.
Oh, that was DeMarco that. I know it's going like that. I know you see it now.
Yeah, I see it now.
Thanks, folks.
All right, so with the exception of a couple mechanicals thrown in, because it's burning, what does it start at? It starts as a chemical reaction, and it puts off heat, so it starts as chemical and becomes thermal. All right, let's try one more. Let's see what else I got that I like. Yeah, let's try that one. Let's try that. Y'all talk on the phone, whether it be cell phone or landline, although most of y'all probably don't even have a landline anymore.
I do.
How many of y'all actually have a landline? An actual phone in your house that's like, not a cell phone. So we have like two people. Yeah, how many of y'all have a house phone?
I got a house phone.
Well, that's okay. It could be cordless. Yeah, I haven't done it yet. I was clicking on it. All right. So you got somebody listening, somebody talking on cell phone or house phone. Somebody's listening to somebody on house phone. That's what I'm asking. What does it start at? What does it become? Listening to somebody talk.
Phone now, can they pick?
Are they putting the phone up? The phone is already picked up and you're listening. Somebody's talking to you. Like last night I picked up, somebody was yapping about some fundraiser and I hung up on it. Well, it started off as where we go. It could be the same. It's very possible to say it starts off and it becomes the same thing. I will tell you this one is not. It's not the same.
Right, it's mechanical too. No, it's not.
It is mechanical. It's not going to start the same in anything.
Electromagnetic, can that be like? Is it thermal? Is it thermal?
No, it's one for radio. You asking what else is the wrong way? There's no thermal. There's no hot breath up there on the phone. When's the last time hot breath went through the phone line? You lost your mind.
I felt mechanical.
So when Dad, let's just say right now, if Dad called you in the middle of the night, you would be able to feel Dad's hot breath from you.
Yeah.
Yeah, I wouldn't call you that right now. I would feel his hot breath coming out. I can call anybody you want. I don't care if it's not hot breath. It's not hot breath. It's not even air. It's not hot breath. It's not the point.
Right. He doesn't smell the hot bread, that's what she's.
It's not hot breath.
It's not what air.
How come I have no answers on the board that says?
That's the joke about that.
Why they not there?
My bad.
Don't bring the phones off. Hot air coming out of your speaker.
They use it air blocking the bathroom.
No. All right, put them on. There's no hot breath coming out. All right, did I get any answers? Did y'all memorize? Is just not accepting it?
No, it's just two and four remaining.
Well, where's that?
Definitely.
Let me hit stop and see what happens. Now, where are my answers? All right, so since I can't find my answers, where did they go? All right, that's a good idea. Let me try to refresh. Something tells me this is not a good idea. Okay. All right, we're back. I don't have, the other one popped up, but this one, I don't have anything. See, if I go back, I have all the answers.
Hold up.
Why you talking to me like that?
Here, y'all send it to me again, since it's not there. Do it real quick. Send me your answer. Drew, send me your answer real quick. Because you didn't get it. I don't know if you got it. Hey, Sean, stop doing what you're doing and answer my question. What? What? Who's there? Who? Who?
What do you like your name?
Alright.
Hey, Sue.
From what I can tell, and all of the ones I just checked, everybody has the right answer that I've been checking and looking through. Because the phone line is electromagnetic, and it's connected to Abigail. You need to move the back. Well, you need to stop. Alright? It's going to start as electrical, and it's electromagnetic. And because the sound is mechanical. Alright, last one, and then we're going to switch. Maybe. Oops, I forgot to hit pause. Pause. Maybe not. That's the battery. Let's look and see if I had something else I like. I might be on the last page. Alright, that's a hair dryer. It's a hair dryer. Alright, last one. Alright, so after you send what it is, I want you to go put your laptop in the car. What is it? It's a hair dryer. Okay, even if you don't use a hair dryer, everybody's seen a hair dryer. Alright, tell me what it is, and then once you get, so after you tell me what it starts as and what it becomes, hit submit, go put your laptop back on the car, so you're done with it. Well, what do you have to do with the hair dryer? Get out of here. Got 45 minutes. I need 3 formulas, so 45 minutes for what? No, that's how it's turned fish. We gotta learn how to do the formula so you can do a live right now. Y'all might be taking from Rugrats. Because it's mandatory to dress up as Sonic for Halloween. Yep. You would probably do that if you've been here. You would have done that if you've been here Not the laptop, the phone. You have that one. The clock right there. Right up there beside mine and Jeremiah's.
What's my vibration on?
Let me see.
Oh, it's not yours up there?
Listen to mine. Huh?
I just have her put it over.
What's there?
Put it over.
Who did? Oh, you didn't put your home over here? Where? Your home over here?
We're laying off my.
You in?
You got the video phone. We're ran off.
Really in good. Not here.
It ran off my phone.
Give me your phone. Hey, I got money. I got money.
You look really good.
No,
I like the way I picked that. Okay, now, go ahead.
It will be fine right there. So then- Alright. Moving on. I have to call you. Now, if we can move on. No.
Abigail!
You need to take your stuff to this back. So you can't be quiet. Give her a phone if you have a phone. Get here. I told you, Rachel, now, if we can move on. Now, we're gonna learn 3 new formulas today. Part of what we're gonna do, you would have done in middle school, and some of you are gonna remember some of these concepts. Even if you did not have the best experience, you will remember some of them. Now, all types of energy can be divided into 2 forms. Whether we talk mechanical energy, nuclear, chemical, electro, or thermal, they can all be divided into 2 forms. Okay? Now, the 2 forms that we're going to talk about are kinetic energy and potential energy. Stop talking or I'll take my time at lunchtime. We need to get through the formulas. We need to be able to calculate them. Some of you are doing a fabulous job with the formulas, and some of you are lost. Pay attention. Now, I do not bring this one. Now, those of you who are doing a fabulous job with the formulas, that's because all the formulas work the same way. You know what you're doing. They're all repetitive. Find the formula, plug in the numbers to the algebra. Those of you who are not doing a great job, at this point, I'm sort of clueless as how to help. Sort of, you need to come get help from somebody. Okay? The formula card has the formulas on it. There are 3 formulas we're going to learn today. We're going to talk again about where to put the numbers and how to rearrange them. So, can anybody tell me what they remember about kinetic energy? Which one has to be still? Potential has to be still. Kinetic has to be doing what? Moving. All right, so kinetic energy is energy of motion. Okay, so and that's the thing I want you to remember. In order to be kinetic, it has to be moving. Okay, you cannot have kinetic energy if it's not moving. Now, on the quiz we're going to take, I don't know if it'll be tomorrow or what's tomorrow? Tomorrow's Thursday. Tomorrow, Friday. One of the 2 days we're going to do a quiz. And there are going to be some examples. And I'm going to ask you, is it kinetic or is it potential?
What's the quiz going to be on?
Yeah. All right, on the 5 types, on this, and on calculating with the formula. Now, people get to the point they're like, well, I don't know if it's kinetic or potential energy. And I'm like, what do you mean you don't know? That's exactly my point, DeAndre. I don't understand at this point in your high school career how you can not know if it's kinetic or potential energy. If the object is moving, it's what kind of energy? It's kinetic. If it's not moving, it's what? It's potential energy. I don't want to hear about it right now. Now, a lot of people, I don't want to hear about it. Shh, Abigail, hush. Abigail, shh. You can tell them at lunch. Potential energy, a lot of teachers will teach as stored energy. Now, it's a really nice definition, but nobody ever knows what stored energy means. Okay? Now, we're going to define it. Is energy due to position? Okay? We're going to use this definition. Energy due to position. So, when we talk about potential energy in a minute, and we calculate, some things are going to have a potential energy, and some things are not. Okay? Some things are always default. Everything has a potential energy. The answer is, no, it doesn't. Because you have to have energy due to its position. And some things based on its position don't have potential energy. And we're going to talk about how that works. Now, does everybody have what they need? Or do I need to wait? No. I can go. All right. So, we're going to start with kinetic energy. Now, again, in order to have kinetic energy, you have to be moving. I don't know how to make that any simpler. So when we talk of examples about kinetic energy, if it says a ball bounces, okay, that's a great example. It has kinetic energy because it's moving. If it says a car rolls, it has kinetic energy. If it says an arrow flies across the field, it has kinetic energy. Okay? And those are just three. You could do this all day long, talking about things that are moving. When you walk to the lunchroom, you have kinetic energy. Jesus was moving his knee a little bit. It has kinetic energy. Anything that's moving has kinetic energy. Next, science is yellow car. I want to show you the formula because then don't get it. One, I'm going to show you a different way to write it, and two of them are combined on the sheet. If you look at kinetic energy formula, kinetic energy is written 1/2 mv squared. Now, most students struggle about 1/2. They don't know what to do with it. Okay? Now, we can leave the 1/2 if you like. But most people struggle with it. So, in math class, that is the same thing as extending that line straight out. So it is the same thing as writing mv squared over 2. I'm going to. I got to write it down first so we can get out of the way. All right? It's the same thing as writing mv squared over 2. Now, for some of us who cross multiply the way I show it, it makes it a little easier to solve the equation if you write it that way. Now, what does the M stand for? Stands for mass. What does the V stand for? Velocity. Now, what is the most important variable in this equation? The one with the exponent. So which one would it be there? The v, or velocity. Okay? And the reason is exactly what Jeremiah said. It's because it's squared. Okay? Velocity is going to be more important because it is squared. Okay? I'm so smart. I was just over playing. Sorry. All right. Can we move on to potential energy?
No, what's this?
What? That's a cue. All right. So potential energy. Now, potential energy is energy due to position. So, this would be, for example, a swing pulled back. All right, you guys have all, at some point in your life, gone to a playground. Sometimes, sat on a swing set. If you're sitting on the swing, you're just sitting on the swing, it's hanging straight down, and you're sitting on it. Does it have any potential energy?
Yes.
The answer is no. In order for that swing, Rachel, I know you hear me talk. Then stop talking to. If you want to have potential energy, the swing has to be pulled back. Okay? When the
Get out! Get out! Get out! Wow. No, we're not going to be able to.
All right. When the swing hangs straight down, does it have any potential energy? The answer is no. In order for the swing to have potential energy, you have to push back, all right, and give it some height, some position. Once you've done that, you give the swing potential energy. But when it's just hanging down at rest on the swing set, it has no potential energy. You've not done anything to change its position. It's just hanging there. You have to do something to change its position. Okay? At the moment, the calculator is sitting on the floor. Does it have any potential energy? No. I don't like the definition of stored energy because some of you would tell me it's just stored energy this fall. That's got potential energy. No, it doesn't. In order for it to have potential energy, I have to change its position. If I put it here, now it has potential energy because I've changed its position relative to the floor. Okay? Now, if we pull a swing back, any of y'all ever, no, none of y'all would ever do this. Any of y'all ever take rubber bands and stretch it back and shoot paper across the room at people? Okay? Alright, so a stretched rubber band. That has potential energy because you pulled it back and you're just waiting to let it go. That has potential energy. Say what now?
I said, I know about the potential energy being in elastic because I did a project on elasticity learning how to do potential energy.
Okay. We can certainly talk about stretched elastic. Now, I'll just say stretched elastic and clothes. Some of you might only have on elastic in some underwear. Some of you might have on stretchy fabric in some pants or in a skirt, all right, or some other fabric that you're currently wearing, all right? But stretchy clothing, all right? Don't believe in clothes. Well, thank God you're required to wear them. Now, the next formula is the reason I need you to look at the yellow card. Okay? The state has written this formula in a very weird way. Tanya, if you look at the card, find PE. Look at the way they've written this formula. All right. So you found PE? All right. You see how they wrote the little g? First of all, the little g just means gravity. You don't need it. So I'm going to take it off. So they wrote PE equals what? MGH equals FG. Now, that is two separate formulas. Okay? That's two formulas. This actually breaks apart into PE equals MGH is the first formula, and PE equals FH is the second formula. Is this where the G came down? Let me move my H closer. There, like that. G. It's a G. It's a G. Okay? Do not break that, Jameer. Well, we just can't afford to replace it. No. 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 Now, what is the difference between the two formulas? How do you know which formula you're going to choose? This formula has what? M. So M stands for what? Yeah. And F stands for what? All right. So, what unit will you look for in the word problem? A mass will have what? All right. I heard kg and I heard Newton. So which one has what? Mass has kg. Mass has kg. Yes. All right. So you have to look at the word problem to decide which formula to use. If it has kg, you're going to pick the one with M or mass. If it has newtons, you have to pick the other one. No, it will not have both. Unless they just give you extra to throw you off. I will not do that to you. Okay? Nishan. I'm so hoping I see Mr. Holloway today. Oh, I'm good. Okay, I'm good. Yeah. The G just means gravity. Technically, you can take that out. It won't hurt a thing. That's force and that's height. Okay? Now, what is the most important variable in potential energy? Height. Okay? It's height. It's height. Because if you don't have any height, you don't have what? You don't have potential energy. All right, can we try some problems? If you can use the formulas and plug in, this is very easy. Those of you who understand how to find the formula and plug in, this should be very easy. M times G. What's G? What have we learned G is this semester? Exactly.
Math times 9.8 divided by
Mhm.
Will they
Will they what? No, because what's G? Uh-huh. Stop with that. Got off of the hour. Jeremiah. Stop.
Oh, you know, the phone.
All right. So we want to find kinetic energy. Those of you who know how to do it, just off to the left. So those people who don't know how to do it can get help. All right, if you know how to do it, just use the calculator and find the answer. Don't offer anything. But there are several people who are struggling, so let them get help. Now, if you want to find the answer, find the question word. You can find the answer. Alright. So what are they asking you for? They're asking for kinetic energy. Okay? So what formula is the kinetic energy formula? Okay, so KE equals mv squared over. That's fine. Then you just sit there and be quiet till we finish. Okay? So which variable are we solving for? The KE. Alright, so we need M and we need V. Hold on.
You want to write the question down?
Yes, you did. Now, for those people who are struggling, when you look at what they gave you, what is a kilogram? It's a mass, right? So that means it has to be plugged in for what? M. It has to be plugged in for M. Times the V is the what? It's the velocity. The velocity is what?
Yes.
So we're going to put it here with the V. Now, you have to remember that the V is what? You got to square it. And a lot of people forget that step. Divided by 2. Now, at this point, your KE is already by itself. All you have to remember to do is do it correctly in the calculator. So, DeMarco, when you punch this in the calculator, what would you have to do first in math class? Please excuse my dear Aunt Sally. Remember that saying you learned probably in middle school? You got to do your exponent first. Okay? So you got to square the 10 first. So 10 squared's got to be done first. So on your calculator, 10 squared is 100. Then times 5 and over 2. So you're going to get 250. Now, once you get that, what's the unit we learned for energy? The energy unit we learned on Monday. We put a J on it. Okay? Energy and work have the same unit. All right, Drew, what was the question you wanted to ask? I already answered it? Okay. Yes, Abigail. All right. Abigail wants to know why we picked this formula. Why do we pick this formula? That's right. It's asking for kinetic energy, and this is the kinetic energy formula. Okay? Everybody okay with that? Okay. So, in this question, all right, it's asking for mass. We've got two formulas that ask for mass. All right, so it's got mass, so how are we going to be able to narrow it down? Because a lot of you are going to be stuck on this one. Okay, it wants mass. All right, some of you have already yelled out the answer, but those are the folks who already know how to do this. All right, so for those people who are struggling, all right, how many formulas have we learned today that have mass in it? Okay, we have KE equals mv squared over 2, and PE equals mgh. And we've got to figure out which one to pick. So look at the question. Are there any words that should narrow down our choice? Abigail, is there anything in there that might say to you which one to choose? In the question. Yes. Can you figure out which one we should pick based on the question? No, you don't. Okay, it gives you a velocity of 5, which is important. Hold on. Are there any other words in that question that might jump out at you and say, I know I need this formula because it says these words? Hush, I know you said. I'm saying in the question, are there any words in there that would say to you, I need this? Yeah. Okay? Because it says kinetic energy right here, that should tell me I need this formula. Okay? Are you with me on that? Okay? I don't know, I haven't plugged it in yet. Now, is everybody with Abigail on how she picked that formula? All right, did it give me a kinetic energy? Yes. What is the kinetic energy? It says it's 50. 50 kinetic energy, so I'm putting it here. All right? What are they asking me to find? So we're looking for M. All right, what's the velocity? 5. Now, Jeremiah, we need to do what to it, you said? Square. And then multiplied or divided by 2. Now, it will always be divided by 2. That's part of the formula. So if I'm sitting in math class, what is the first thing I do to solve for it? We can do the exponent first, that'll be fine. Let's go ahead and take care of that. So we get 50 equals m 5 squared is over 2. All right, now what do I do next? Cross multiply. Hush. What's what? That's half what? 50 times 2 is equals m times 25. All right, so now what do we have to do to find the answer? Divide by 2. All right, and what unit goes on math? KG. Question. You got a quiz? Questions about how to do that? Now, again, the people who know how to do this are the same people who I know are following me. Those of you who still can't do it are still zoned out and not with me. You think I get it? I think we're getting there, yes. All right. What if we want to find velocity? Chris, stop. What if we want to find velocity? What's the only formula that has velocity in it? Kinetic. The only formula that has velocity in it is kinetic. Now, let's make sure we can all find kinetic. Because you have to do something we haven't done this semester since first week of school. All right? What's the kinetic energy? Okay? What's my mass? Times b squared over 2. All right, how am I going to solve? Okay, so 100 times 2 is?
200.
Equals 15 times b squared. So I'm going to divide by 15. I like that. What's 200 divided by 15? I don't know. I don't have a calculator. Y'all don't have a calculator. Oh.
13.3.
All right, so in math class, what do y'all do to get b squared by itself? Okay, I just wanted to make sure everybody remembered that. So you take the square root. So b equals, what's the square root of 13.3? 3.6? All right, and what is the unit for velocity? Meters per second. Question? Any questions? Everybody feel okay about kinetic energy? Because we need to talk about potential and make sure we're okay there. Carlos, pick up that paper. It did not make the trash can. No, it didn't. It didn't even come close. All right, let's talk potential. All right, I don't have potential in there. All right, let me hear it loud. Ah, if this is the information you're giving in the problem, which formula are you going to pick? Jeremiah, is there a reason that you are out of your chair? It is not. I'm just asking, how would we solve this?
You have to look up our name.
Alright. Alright, so everybody remember that we're going to use the 9.8 for G then, because that's what I keep hearing. 147 when I multiply all that together. Alright, what unit do I get? Is it 1470 or 1?
It's 14,000.
Alright, what unit do I put on potential energy? Okay, now. If I want to find mass, what formula am I using?
The square down.
Alright, look what I gave you. Am I using KE or PE?
PE.
Alright, so I want PE. Alright, so PE equals, watch your language. PE equals MGH. So what's my PE? What's my PE? What's my mass?
It's M.
No.
M.
Okay, what's my G? And what's my? Alright, so how would I solve this in math class if that's what I want to find? You got to multiply. It's usually called combining like terms in math class. So what's 15 times 9.8? Y'all want the calculator? 147. All right, how do you solve? By. That's why I asked this. Most people, when we get to the test, y'all want to say divide by 100. What is with the M? You got to divide by 147, so M is by itself.
They go by that by 100.
You got to divide by what's with your variable. You got to divide by 147. No. People said it backwards. I didn't do it backwards. Okay? You got to divide by 147 on both sides so that you get that. Question. All right. Last one, and then we're going to talk homework. Because yes, you have homework tonight. Really sorry. All right, last one, and then we're going to talk homework. So, which formula would we use here? Potential, and do we need MGH or FH? All right, so what are we solving for? The height. So that means I've got the other two. So what's PE? And what's height? So how would you solve? By? Height equals 6 what? What unit goes on height? M. Get M for meter. All right, let's talk homework.